Hi guys, welcome back to a new video here on Flow's Boatworks. Today we're going to be talking about the electrical system on my new Viking 50 Custom. It's the biggest, I think this is the biggest Viking model boat that is out there, fully functional worldwide. At least I've not seen anything bigger than what I'm building on YouTube. This is what I'm getting my information from, apparently. But today we're going to take a look at the electrical panel. I've fully modeled this. This will be my last boat. You've probably seen it on the channel. Has also been quite a beautiful boat, but the build process was quite different. I just put in the stuff that I needed at the time that I thought it was perfect, and it was not perfectly like a perfect fit. All the components did not perfectly fit within each other, and I actually did a complete remake of the electronics and a main electronic panel on this boat, also due to making a ballast tank in the boat, but has also a lot of different reasons. So for the next boat, for the Viking 50C, I wanted to do it perfectly, do a perfect setup of the electronics, a very compact way, and also do not do any electronics that I do not need. So just really the basics, but still give all the real scale RC functions that I want in the boat. So this is what we're going to talk about today. We're in Onshape. Actually, you can probably find this panel if you want under the public domain, and also I will put a link in the description below, so you can actually use it if you want to. It's perfectly good for you to use if you want to do that. And this is set up to be a panel with 2 batteries plugged in series, and also with 2 separate engine controllers, ESCs. I think that's what they're called. ECS, no, ESCs is what they're called. I think. I don't want to redo the font on here. So I'm gonna. And of course, I do have some push buttons as well for the various systems. And you might be asking yourself why there are so many ways to plug in stuff. And this is because this panel is completely can be removed from the boat within like 5 minutes. You have 4 screws on the top, 4 screws on the bottom, and you can remove those XT60 connectors and those 4 XT90 connectors, and then you're good to go. You can completely remove it. Also, you have here some servo leads that you can unplug, then you're good to remove it. So it's not a lot work to remove that panel. This has a reason, is because I want to finish the panel completely before actually finishing the boat, because there are times when it's better to work on a panel and times that it's better to work on a boat. When it's 2 degrees outside, I don't want to work in my garage on the boat, but I can work on my panel and on a whole electronic system. This is the reason for that. And also, if there's any fault, any problem going on with the panel, I actually can just remove it and insert a new component or so. So let's just go over the panel. You can see this is the layout of the boat. This is the front. At the top is the front of the boat, the bow, and the bottom is the stern of the boat. And I can also show you where the panel will be located. I use SketchUp for the planning of the hull of the boat, and I use Onshape for all the other components, like all the technical components of the boat, and also obviously the electronic layout of the boat. So this is the hull of the boat, and I have this will be where the electrical panel will be located, right in this position right here. Down below here is the space for all the excess cables that you can drop in like that, so you will not see any excess cables, which will quite neat. But if you want to remove the panel, it's no problem. You have screws. Let's just go look at the screws. This will be the screw panel. So what is quite nice. You have those M3 screws right here that fit in perfectly, the nuts, and you can actually screw it down from up here. And this green bar will be screwed and also glued to the actual plywood of the boat. So this is kind of the component that fits on here, and then the panel will be screwed onto. And you see here that this is a completely level panel that goes up on here, and you will have water drainage if there is any water coming in. I will not think that, but in case of, there will be holes for the water to drain through. Also, you'll forcibly see holes up here and here and here and here. These is something that I planned on doing, but actually I didn't then, because the only wet area on the boat is going to be this, but this is going to drain down here, and this is where the bilge pump will sit, but we will come to that later. And here is the battery area for the boat. And you might be wondering why I do such big batteries. The reason is because I don't want to mess around with lithium batteries. Just not completely comfortable with that. I do have lithium batteries in some other projects like my aircrafts and airplanes, but for that boat I don't specifically consider it weight critical. So this is why I do away with AGM batteries. It's going to actually be AGM 40 amp hour batteries. It's going to be something like this. This is the one I have right now for the trawler. I'm probably going to just buy a second one of this, and then I have two batteries in series connected to the hub. It's going to be 24 volts for the 2 engine control units. So let's go through the panel. The first layer here is going to be the 12 volt circuit board. It's just as a basic 12 volt Amazon circuit board, not much to it really. All the components that I use in this panel will be linked in the description below. Amazon affiliate links. If you want to build the panel yourself, you can do that. You can also change components or stuff as well. It doesn't really matter. These bus bars, I'm not completely sure how we'll do the managing of the cables, but what it will do is there will be a 12 volt bus bar and a 24 volt bus bar and a combined minus pole going from the batteries, as I need also 12 volts for a variety of different components like the, let's see what we have here. The bow thruster will be 12 volt. It will be a brushless bow thruster, not water cooled, just air cooled. It will have interior lights 12 volts, horn is going to be 12 volts, courtesy lights going to be 12 volts, cool pump, bilge pump, all going to be 12 volts. So this is why there is the 12 volt bus bar, and 24 volts essentially only is going to be driving the engines. Okay, so this is what this will be like. The bus bar is just a standard bar that connects cables. It's just a cable connector really. Up here I have 3 screens. I mean, I do want to know the voltage of all my batteries, but this is really just finicky stuff. You don't really need that, I think, but I think it looks pretty cool. We have the main bus connected to battery 1, battery 2, probably shows around 24-25 volts fully charged. And you have battery 1, battery 2 separately, showing the voltage of each battery. And down below, of course, you plug in battery 1, battery 2, and all ECS controllers. Is it ECS or EC? I don't know. Up here, you have a plate for the actual water cooling system, which is quite nice. Water cooling, sorry guys, the water cooling system will also be powered by 12 volts. It will have a sensor, temperature sensor connected to one of the ESCs, and this will then trigger a water pump and pumping through and both ESCs and both engines at the same time water to cool down the components. This will be completely automatically controlled, and you actually have buttons to control it down below, but we will talk about the buttons later. Right there is the receiver for my radio link. I got a radio link transmitter. I don't know what it's called exactly. This is what I have, AT10. It's a 12-channel radio link controller. Didn't order it from this side, but that's essentially what it is. I'm pretty happy with it. It has a lot of channels. It's pretty cheap, and I don't worry about it at all. Being a cheap controller actually. This is the receiver. It's about a 16-channel receiver, and also what I've done is because the plugs on the receiver for the servo cables for the servo leads are so small and so tight to each other, I actually wanted to do it clients for the receiver that are not mounted on this plate. Clients on the receiver that are mounted on this plate is going to be the 4 relays. That's basically it. All the other servos will be plugged in separately because these are components connected actually to the boat, like the bow thruster controller, like the ESCs, like the rudder in the back, also the outriggers that go and do some fishing. These are all going to be collected through here with numbering, and the reason for that is that it's just easier to connect those. It's going to be with servo extension cables, pretty easy stuff, and I measured this, and this is going to be, and they're going to be glued into here. It's just way easier to remove it and plug it in than it is from this. And also I don't want to damage this by plugging it and from too often. Let's continue here. This is the XT60 connector socket where I have the bow thruster cable. It's going to be just a 12 volt main power cable for the bow thruster that goes into the ESC. The master is going to be connected to a push button switch that is lockable, that is controlling probably the actual power towards the receiver from one of the ESCs. So that's, I think, the most easy way to just shut off the whole thing, shut and switch on the whole thing without doing kind of a difficult relay situation that I did on my other boat. But this is a way easier option that I found might be working actually. I will be controlling probably with the master switch, like the red or the black cable from the ESC going into the receiver, powering off the receiver essentially. I have interior lights. This is where they plug in, controlled of course by the buttons down below. I have my horn, 12 volts car horn, nothing special, like €5 on Amazon. I have a courtesy lights. This is the blue, going to be all blue courtesy lights in the gunnels in the cockpit of the boat. So they're going to be right here in the boat, and also on the actual fly bridge, on the bridge of the boat. It's going to be also some blue lighting, some courtesy lighting, which will be looking pretty good. I noticed that I don't have any navigational lighting here, and the reason for that is, I'm going to talk about that later. Courtesy lights, I have the cooling pump and the bilge pump. I got two pumps in the boat, one cooling pump, one bilge pump. Keep it simple. In the boat that I have now, the Troll, I have 4 pumps with ballast pumps, and ballast pumps are way too difficult. I will not have any ballast probably in this boat, as the batteries will be doing the heavy lifting on the ballast side. This will also be now cooling pump and bilge pump. Cooling pump, as I said, controlled by this cooling pump controller. Bilge pump will be controlled by the receiver, just manual bilge pump. Let's go to the buttons. I have a master switch, a second master switch right there. The reason for that, actually I don't know it, because on my different boat, the master switch, the main master switch, is on the pilot house. You switch it on, switch it off on the pilot house. And if you drive without the pilot house and you want to test something, you don't have the master switch. So this is why I have a second master switch here. But actually, the master switch on this boat is going to be located on the back side of on here, right? And this is actually connected to the hull, so I don't actually need that. So we might turn that off, or might not use it anyways. Might have to think about that maybe. Well, cooling is on here. The cooling pump, as I already said, this cooling switch controls the main panel of the cooling controller, and you can also override it to test it out, or what's more important, if you lift out the boat and you want to put it back towards your apartment, you want to have it all dripping down water, you're going to use the override button just to get that excess water out of the system, and then you can store it comfortably. Interior lights switch, and also have a spare 1 and a spare 2 switch. Whatever I might choose to do with those. And if I want to build a more stuff towards boat, like maybe someday in autopilot, didn't get around to actually study the autopilot material with Arduino and stuff. RC Test Flight is a good channel to watch that if you're into that. RC Test Flight is pretty cool. There's a lot of long range missions, but I'm fully into that with that boat. Obviously, that's not a long range boat. It's a planning boat that will go very fast for a very short time. But autopilot would be quite fun. Maybe there's an easy way to do an autopilot, or to just a heading hold or something. And this is the plate for that, if I want to choose so. It's quite long as well. It's 84 millimeters enough space for an autopilot, or for anything else that you might want to build into that panel. You can use that for. And also down here is the connectors to the actual removable deck panel. So this whole thing here, this assembly right here is removable. This is the only thing which is removable. And you will have the outrigger server mounted to it. You will have the navigational lights and the courtesy lights with separate channels mounted to it. And these two avionics style connectors will be the thing powering the helm. So yeah, guys, this is really it. Pretty cool, I think. I think I didn't forget anything, and you can use it for your own project if you like. All the components are standard components right there, easy to use. I will put the links of the components in the description below. And if you have any questions or any recommendations to my build, please do me the favor and write a comment below. I'm happy to take all criticism and all constructive help that I will take all the help I need. Basically, I'm still not a pro on this subject. So see you in the next video, and stay tuned.